Aloha everybody, this is Gigi from Kauai Community College. This video is on the ratio test for convergence of infinite series. So let's get started here. Okay, so suppose you have an infinite series with positive terms, and when you take the limit of the ratio of the k plus first term divided by the kth term, and take the limit as k goes to infinity, and it equals to some number L. Well, L could be these scenarios. If L is in between 0 and 1, including 0, but not including 1, okay, meaning L is a positive number, less than 1, or could be 0, then the series converges. 2, if L is greater than 0, then the series diverges. So those two scenarios does not include when L is equal to 1. Okay, did I say 0 earlier? I really mean when L is greater than 1. Okay, so if L is equal to 1, then what do we say? The test is inconclusive, and so we have to try some other test. All right, so here is an example. Here's a series. The first thing we would have to do is to go ahead and verify that they are positive terms. Well, of course they are, because k starts from 0 to 1. So the first term in the sequence would be 0, right? The second terms in the sequence would be 1 over e. And then the third terms in the sequence would be when k is 2. So that would be, not sequence, but in the series. Sorry about that. I should have just go ahead and say plus. Plus would be 2, so that would be 4 over e squared, and so on. And you know k is positive, and then e to some power is positive. So the sequence have positive terms. Okay, so that's good. Okay, the second condition is, let's go ahead and take the limit. Okay, let's go and take a look at the limit of the ratio of a sub k1 plus k plus 1 divided by a sub k. Now, when you plug in k plus 1, this is what you will have. This is a sub k plus 1. Okay, divided by means multiply by 1 over a sub k, right? I skipped the writing down the division problem there. Division is multiplying by the reciprocal, so that's what I'm going to have there. Now, e to the k power is going to get divided out with e to the k power on the denominator, so you'll have just e to the first power, or just e. And then we can expand out the k plus 1 square, and you'll have that. Matter of fact, we can actually go ahead and factor out the 1 over e. And then the trick here is to divide by the highest power, right? So you have seen that trick before. Okay, so then you will have just this here. This goes to 0, this goes to 0, and the limit would be 1 over e multiplied by 1, which is 1 over e. So we know L is 1 over e. 1 over e is less than 1, because e is approximately 2.7, so 1 over e is roughly 1/3, which is less than 1. So the series converges by the ratio test. Okay, here's another. K factorial over 4 to the kth power. Well, k factorial starting at 0, 0 factorial is defined to be 1, by the way. So you'll have all of these terms are going to be positive, so that's good, because k 4 to some power is going to be positive. Okay, and now let's go take the limit. Again, the limit as k goes to infinity of k plus first term divided by kth term. Okay, division means multiplying by the reciprocal here. Okay. Again, 4 to the k power, gonna cancel with 4 to the k power here, so you'll have just 4 to the first power, which is 4. And then k plus 1 factorial is k plus 1 times k minus 1, and so on, all the way down to 1, right? And then k factorial is k times k minus 1, all the way down to 1. So you can see that all of these here going to cancel out, and that will just leave you with k plus 1 on the numerator. So we will have the limit as k plus 1 divided by 4. That would be a big number divided by 4, which is big. So what does that mean in terms of our ratio test? This L is big. So since L is a number, is something larger than 1, right? Big number is larger than 1. The series diverges. All right, one more. Are the terms positive? And the answer is yes, because k squared is going to be a positive number. So you will have a the first condition is met because all terms are positive. Okay, now let's go take a look at the limit. The limit as k goes to infinity of k plus 1 first term divided by kth term. Again, division is multiplying by the reciprocal, so that's what we're going to have. And we expand out the denominator there, multiply across. And again, the trick here is what? Divide by the highest power. So then you will have that. That is not there. So then you will have 1. 1 is your answer. Okay, so 1 is your answer. What happened when L is equal to 1? We say, no, the ratio test is inconclusive. We cannot tell what this is. Okay, but if you think about this one right here, we've seen it before. What is that? That is a P series with P equal to 2, which is greater than 1. So the series converges, right? So the series converges. We know that from previous lessons. Okay, but as far as trying to use a ratio test, it doesn't work because L is equal to 1. Now, that doesn't mean that the series diverges. It just means we cannot tell. All right, so be careful of that. All right, so that should be plenty of tests for you to practice, and make sure you choose the most efficient test.